In this video, I'm going to show you how I repurposed one of the oldest tricks in video game design to create this performant, multiplayer ocean from scratch for my Pirate Battle Royale. It's surprisingly simple, and this is far from the only progress I've made since last video, so stick around. Last time, I had a working multiplayer prototype in Unity, and after some deliberation, I started from scratch with Unreal Engine 5. They call it that because it's like 5 large softwares rolled into one, so learning to make a game solo with it can feel like drinking from a fire hose. I took a little break for Hot Girl Summer, but when I jumped back in, I decided if I focus on relevant topics and don't get distracted with things I don't need yet, I can make meaningful progress without getting overwhelmed by this enterprise-level software. So I've identified 3 major topics to address this video: online multiplayer, ship movement, and water. First, I followed an Udemy course to get the basic server client host join features implemented in C++. It's good enough for now, but I'll eventually need to add player lobbies and matchmaking. Unreal has a simple option you check to enable multiplayer, but it's not quite so simple. Plenty of things work quietly without revealing how involved or powerful they are. More on this in a moment when I migrate my ship movement into the multiplayer prototype. Last time, I handled all of the ship movement input vectors myself, and I just added them together. I could do this again, but there are so many other ways to move an object, and I'd like to understand them. I knocked out a few more tutorials on custom character movement and realized the character movement component is the gold standard provided by Unreal. But I wanted to make my own system, so I initially avoided this. When you add a class, there are a lot of options to inherit from, and each is very well documented, but it's honestly pretty jargony until you've gotten your hands dirty. So I just started pressing buttons and taking mental notes, experimenting with ship movement in 3 different ways, and switching between approaches whenever I hit roadblocks or uncovered new information. Eventually, I followed a kinematic tank tutorial to make my ship align with the average normal of the ocean surface, and this was good enough in the moment, and I moved on, but a few weeks later, I put it all together and I realized that this approach was not going to work for a multiplayer solution. After all of this trial and error, a little research revealed that the character movement component, which I mentioned a moment ago, has built-in client prediction, replication, and more, which are all advanced features that reduce the perception of latency, simplify network synchronization, and provide a foundation that makes cheating harder. So, I re-implemented the movement yet again, and my problems were solved. I'm still working on extending the character movement component class for a truly custom solution that still taps into those higher benefits, but for now, this is working great. With movement sort of figured out, I could finally focus on what my water surface would actually be. Researching video game water, I quickly realized that Unreal's experimental water solution and other free options wouldn't work for me. They're a bit overkill, and they're not designed for multiplayer or large maps. I also just don't understand them. I want a deep sense of control over not just the water, but how my ship interacts with it, so I decided I'd be making my own ocean. I was testing movement on a sculpted landscape, but now I want that landscape to move in real time. Unreal Engine landscapes, however, are static by design. They're optimized for rendering large, open environments efficiently. Features like level of detail systems and pre-computed physics interactions often rely on fixed landscapes. In short, Unreal's large and visually impressive worlds come at the cost of real-time flexibility. My first admittedly naive attempt relied on the real-time mesh component. Instead of deforming the landscape, I tried regenerating it over and over. It's horribly choppy and it relies on my custom movement that checks from the ground from way high up so I don't fall through, but I'm not about to waste time trying to make this more efficient. It's clearly the wrong approach. I'd like a dynamic landscape, but those are hard, and even today, few games have implemented them in ways that stand out. In games with destruction, such as Battlefield or the old Red Faction, destructible components often consist of interconnected blocks or pre-fractured meshes that break apart into smaller pieces. Increasing the number of fragments improves realism, but comes at the cost of performance. To balance visuals and efficiency, Battlefield has predetermined collapse patterns for large objects, along with plenty of indestructible elements. Even Minecraft has a static layer underneath all the interactive ones. A water surface, then, might seem like the ultimate dynamic landscape. However, most water systems rely on shader materials and textures applied to simple meshes, creating the illusion of fluid motion without altering the terrain itself. This is called vertex displacement. The GPU redraws the vertices of an object to be more visually interesting, while the CPU retains the simpler geometry for calculating game logic. So a plane of water may distort with wake and ripples, but your player movement is still calculated along an invisible flat surface. When you add in buoyancy, foam, splashes, and such, the illusions all stack pretty nicely. If we look at Sea of Thieves, their water is super performant and allows for beautiful multiplayer ship battles on an Xbox. Rare has a long technical art presentation that dives into their water system, and they use a lot of advanced techniques to get their look. They don't talk much about their physics, but they're almost certainly not constantly deforming the landscape. Since they use stacks of math waves called Gerstner waves, my guess is they sample from the same deterministic function that decides the largest underlying wave for the shader to also displace the ship or other objects along the z-axis. From here they could also calculate buoyancy and wave impacts. It's all pretty cool, but it's also pretty highbrow for me. I don't need the water to look as beautiful as Sea of Thieves, but I do need it to run as smoothly and for everything to be in sync such that two players looking in the same spot see the same wave. Now this is where knowing some old fundamentals comes in. In many older games, especially before attaching a follow camera became standard practice, if you wanted a character to move forward, you had to make the world seem to move backward. Something I did all the time in Game Maker was to make a background that could loop on itself for an infinite scroll. Simple solutions like this come with technical restraints, however. For example, in the simplest scrolling games, you can't even move backwards. Sometimes the map is just platforms or enemies spawning at set intervals. A modern example is Flappy Bird. Your only real inputs are up and down, but the animations and the scrolling background give the illusion of deeper movement. This is foundational stuff. So now in a world where I'd like to make an ocean that scrolls underneath you, the opposite is suddenly obvious. Instead of scrolling the ocean, I added a relative movement to every object in my game on world coordinates, and this keeps every non-water part of the environment moving in unison, creating a pretty convincing illusion that the water itself is shifting underneath you. I'm not going to be wasteful with too many rocks and islands, but having foreground objects really helps sell the effect. I can adjust the speed and direction, and I can even make the water seem to surge up and down with this. Since everything drifts in the same direction, I can have the landscape gradually change in that direction to get a seamless transition from calm to stormy waves as the match progresses. While I was exploring whether making my own water was feasible, I slapped the simplest material on a plane and thought, that's actually pretty good. And then, when I came up with the scrolling technique, I originally thought it was just going to be a fun test, but it ended up solving all my problems and it looked so good that I decided to stick with it. It also saves me the work of making yet another movement system that has to be in sync with the wave appearance, which would be technically doable, and part of me may want to figure out how to make that fancy industry standard level water, but I really love the simplicity of this current illusion, and I've definitely seen hackier things that work. Now that I finally have these working basics, I tacked on this placeholder cannon because I still have to figure out roll switching and camera control, but I can't call it a pirate game without cannons. So far, it all works, but I feel betrayed by that multiplayer Udemy course I've started with because it works when two computers are on the same Wi-Fi, but I haven't gotten the Steam subsystem to work yet. Just another problem for future me, though.
Man, I don't envy that guy.
This isn't quite how I thought rebuilding my game in Unreal would go, but that's why we don't start with dream games and we just roll with the punches. Self-learning is always tricky. Things like YouTube are often the blind leading the blind, but good resources do exist. Initially, I was so hung up on a pure code solution that I was actually foregoing progress. Blueprints are Unreal's visual scripting solution, and I had to accept there's just no excuse not to have a strong grasp on them. They're very straightforward. I was just avoiding them because I think they're ugly and they threaten my fragile programmer ego. One major key for me has been to resist the urge to unravel every thread. Unreal Engine is a behemoth of software. Every little feature is a rabbit hole. As an example, you can bind a key to an action in Blueprints. If you're a noob, maybe. Unreal connoisseurs use the inputs menu. But of course, a connoisseur's connoisseur would create an input action and reference it within an input mapping context. Just kidding, there's an enhanced input controller you need to use if you want to truly be a pro. And you could write that controller directly in the pawn class, but a pro's pro knows that you need a player controller class that handles this all separately. And you see my problem. That's a lot of abstraction for a simple task. Best practice is the goal, but it comes with a huge time sink. You have to explore to learn, but explore in the wrong direction and you'll get lost. I implemented my ship movement 4 different ways before discovering the character movement component is such a game changer. And I'm still working on yet another version. For now, I'm using a stock water material, but I'd like to make my own. And even though this whole time I've been learning all about Gerstner waves and fast Fourier transforms and iambic pentameters, I still don't have anything I like yet. So I decided I'd make this video with all the Unreal progress so far, getting movement and water in a multiplayer world, and then next video, I'm going to bring this world to life with a little art break. Not that it'll be easy, but I'm not going to worry about join lobbies or remote procedure calls for a bit. I want to make the boat pretty, settle on a water style, and even add living islands. Not too many spoilers on that yet though. Now that I'm getting the hang of Unreal, the next video should hopefully take much less time to make. A huge thanks to everyone who subscribed last video and is just along for the ride. I'm not going anywhere. Thanks for watching, take care.